When you start balancing, you realize, oh, but there's a carbon on the left. There needs to be something with carbon on the right. Okay, the next one is that yucky one. Okay, it's that yucky acid that's an exception. So we write the acid part first, then the metal. This is +2, so I need to put a 2 here, and then the metal plus water. The last one, so I just did number 11 real quick. The last one is then a rule 5, so it forms ammonium and ammonium salt. So that one's actually pretty simple to figure out. Okay, the rest of the worksheet is doing ones in words, okay, which you've done and the worksheet would have marked for you. Okay, so those are your 5 rules that you need to know, and you need to be able to apply them and finish reactions with them. Then we're going on to indicators next. So what you actually need to do is you have to draw up this table into your book. So the indicators you need to know in grade 10 are litmus paper or litmus solution, bromothymol blue, methyl orange, and phenolphthalein. So these are indicators you can use to figure out. In grade 9, you did nice practice with these where you tested different substances with indicators and you saw if they were acidic or basic or neutral. So litmus paper, remember you get red and blue litmus paper. If you use red litmus paper and you put it in acid, it's not going to look like it does anything because it's going to stay red. And if you use red litmus paper in a base, it will turn blue. And then blue litmus paper will always turn blue in a base, and blue litmus paper, yeah, will stay blue in a base and then will turn red in an acid. If you had litmus solution, the paper obviously you'll know doesn't show you the neutral color, but if you have litmus solution, it will turn purple in the neutral color. So you can write that there for a litmus solution. Bromothymol blue is yellow in an acid, blue in a base, and green in a neutral color. You'll see the neutral color is basically those two colors added together. Then methyl orange is red in an acid, yellow in a base, and orange in neutral. And phenolphthalein is colorless in an acid, reddish pink in a base, and pink, some books will say light pink in a neutral solution. So take a few minutes and write that down. Okay, once you've written those indicators down, and if you haven't at this point, you can always pause and just write them down. We're going to go on to different types of calculations that you can do in this section. Okay, so then moving on to acid-base calculations. Okay, so I'm actually going to start off going through this, and it's very much going to be mole calculations in the beginning. I will show you alternative ways of doing this as well, but in the beginning, because you know mole quite well, and you seem to understand that well when we did it, I'm going to use mole. So what I'm going to give you is I want to say to you that, for example, sodium hydroxide reacts with hydrochloric acid, and it forms sodium chloride and water. And they've given you the concentration of the base, the volume of the base, which immediately is a bit of a problem because I need to convert that to decimeter cube. And how do we go from centimeter cube to decimeter cube? Remember, King Henry died a miserable death called measles. If I'm going from centi to deci, I would one jump left, so I would divide by 10. But if I'm going from centimeters cubed to decimeters cubed, I need to divide by 10 cubed, which is 1,000. So I need to divide by 1,000, which gives me 0.1 decimeter cubed. Okay, so I've given you the concentration and the volume of the base, and I've given you the concentration of the acid, and what I'm going to ask you is to calculate the volume of acid needed to neutralize the base. So first things first, this is obviously a base here, and this is an acid, and acids and bases neutralize each other. So if you have a bee sting, for example, and it obviously burns, what a bee sting is, it's a little bit of acid that gets put into your skin. So it causes a reaction, and some people obviously it causes a very violent reaction. And if you want to try and ease that burn, because it's acidic, the burn itself, you end up putting a base on it. So that it would neutralize that acid. So a base you could use is bicarb. Okay, so baking soda that you have in the kitchen that you use to bake with, that's a base, and that will neutralize that acid. And a wasp sting, for example, is the opposite. A wasp sting is basic, and if you want to neutralize that, you can put vinegar on that to try and neutralize that burn. So acids and bases neutralize each other. So if you want an acid and a base to neutralize each other completely, you need to have them react in the correct mole ratio to each other. Now, what I mean by that is if you look at this reaction and you balance it, it's actually a nice one. It's already balanced. It's a 1-to-1 molar ratio. So if I say to you, what is the volume of acid that you need to neutralize the base? You need to say to yourself, okay, they need to be in a ratio of 1-to-1. So it really becomes a mole question more than anything else. So what you need to do, I'm just going to erase the question here. What you need to do is you need to work out the volume of this, but you don't have enough information of this, so you start with the base and you go mole. Let's just draw the triangle here because I find that people most often get this triangle wrong, and it is on the data sheet, so it's just a little mistake we make. We often say mole is concentration over volume because we're so used to saying mole is something over something. But careful, in this triangle, mole is concentration times volume. Okay, so the concentration is 0.1, the volume is also 0.1, so it gives me 0.01 mole. Then if I use my mole ratio, 1 mole of this would react with 1 mole of this. So I go 0.01 mole of sodium hydroxide divided by 1 times by 1. If you've forgotten where I got that from, that's from the mole ratios in front. Divide by the one you're with, times by the one you're going to, gives me 0.01 mole of HCl. Then I can go, okay, now I'm looking for the volume. So now volume is my unknown. Volume is mole over concentration, which is 0.01 divided by the concentration, which is 0.2. And if I put that into my calculator, I end up getting a value of 0.05 decimeters cubed, because decimeter cubed is the SI unit. So if I get the answer, it's also going to be in the SI unit, which is decimeter cubed. So I would need 0.05 decimeter cubed of hydrochloric acid to neutralize this base, the sodium hydroxide base. Then for your homework, I'm going to, on Teams, give you a couple more of these to do, where either the concentration or the volume is unknown, and you have to figure out how much of the acid or the base you'll need to neutralize the other substance. So I'm going to put up a separate worksheet. It's not actually in your booklet. And I'm going to put that onto Teams so that you can submit that for next time.